All right. Hi, everyone. Thank you for joining the meeting today. So this talk is going to be about problems that we faced when processing genomic data at Cancer Science Institute of Singapore, where I worked as a research assistant for about a year. We heavily relied on Parcel when implementing genomic analysis workflows. I'll go through some of the techniques we use to optimize these workflows. So if you look back at 10 years, running bioinformatic tools on the datasets available back then was a cheap and a trivial task. But it is much more compute intensive, and the massive amount of data being generated today using next-gen sequencing technology makes it more challenging. Genetics and genomics now are data-intensive sciences. Therefore, it is important to understand the underlying cost of operating a large-scale infrastructure platform. In our lab, we gather and analyze cancer genomics data using large-scale hardware platforms. For example, Aspire-1 supercomputing platform in Singapore and also AWS cloud platform. Swag is a software framework that we have developed in-house using Parcel that is specifically tailored towards running genome analysis workflows at large scale. It is portable across various execution platforms like Aspire-1 supercomputer or even AWS cloud. You can create a workflow configuration with all the input files in BAM or FASTQ formats and mark them as either exomes or whole genome sequence and specify secondary analysis options. Once you submit the job, it will automatically provision the nodes and run the analysis that you have specified in the configuration script. So Genomic Data Commons provides the cancer research community with a unified data repository with tens of thousands of cancer samples. All of the samples are processed using the same pipeline, which has been comprehensively documented and publicly shared. However, GDC does not provide a scalable workflow that would allow cancer researchers to process DNA sequencing samples at scale. So in order to mitigate this issue, we have reproduced GDC data harmonization workflow using Swag framework. Now, it's not important to understand the details of every step here. The point I'm trying to make is that implementation complexity of these workflows can grow rapidly, especially when we want to run at scale. So we have tried to parallelize the workflow as much as possible so that it can scale out efficiently. As you can see in this workflow, there are many steps, including forks that create parallel branches and converging points. So we are using Parcel app chaining via futures to create dependencies across those tasks. Let's look at a simplified version of it and talk about what we have done with it so far. So we use the Swag framework to supplement the data from GDC. For example, the standard GDC pipeline only provides somatics nibs. Therefore, we added additional tools to generate somatic indel codes on GDC data. As of now, we have processed more than 8,000 tumor normal pairs from cancer patients in TCGA. Our target is to process all of the tumor normal sample pairs in TCGA across 33 cancer types. That is going to be more than 10,000 DNA samples. In order to facilitate this process, we had to create another GDC download workflow using Parcel to automate the downloading process as well. So this is rather an unusual application of Parcel to overcome some of the restrictions enforced in Aspire-1 head node. The problem is we are not allowed to run long-running processes on the head node, but downloading DNA sequencing data takes a long time. So one DNA sequence data file can be around 15 gigabytes, and one batch of DNA samples can take up to 10 terabytes. So within the main Parcel application, we create an SSH tunnel to the head node and open up 3 separate reverse forward tunnels to allow traffic to travel back and forth between workers and Parcel. So we use the local provider with SSH tunnel to execute apps on remote nodes. So these reverse forwarding tunnels are baked into the overall program, the main application. But you should bear in mind that workers might get killed arbitrarily by the monitoring agent of the head node. So your apps need to be resilient against hard exits. So while we absolutely appreciate what the Parcel core team has done all these years, there are a few things we would like to see that would help us to utilize the framework for some advanced use cases. One drawback in Parcel right now is that task packing is done at the executor level, not at the DFK. So when you submit your workflow, your task will be assigned to an executor immediately when you have multiple executors configured in your Parcel configuration. But what if these executors have different capacity levels? This is possible when you're dealing with a shared compute platform. Also, what if one executor has finished executing all the tasks assigned to it while another executor is just overpacked? So in order to mitigate these issues, Parcel must be made aware of the workload of the underlying executors at runtime. So that is one use case where we would like to see more support of. And another feature that we would like to see supported is remote task execution. So this is related to the use case scenario that I demonstrated earlier. Well, there are certain scenarios where you want to execute your workflow remotely, and Parcel right now does not fully 100% support it, especially when you have a non-shared file system. You need to include additional checks in order to handle edge cases. Yeah, I would like to thank all of our internal and external collaborators for all the help and contributions. Dr. Pate from CSI Singapore has been leading this project from its inception. Special thanks to Ben and Zhuzhao for helping us with all the Parcel-related issues. That's it from me. I'm happy to take questions if you have any.
Okay, yeah, thank you. That was very good and good timing as well. Any questions?
I have one. So you're using two different executors, right, to do different resource packing there?
Right now, yeah. So we are allowed to use. So actually, we are using one executor because using two executors is not feasible due to this limitation in Parcel. Yeah. So the limitation we have in the underlying compute platform is that, for example, as I mentioned here, so we have access to two queues, one medium queue and one long queue.
Yeah.
But the resources available to you on those two queues are different.
Yeah.
So we don't know how Parcel would allocate tasks to those executors.
Okay.
So if it ends up allocating everything to long queue, then you can't provision much nodes on the long queue. So
yeah,
as a user, you want to squeeze out every bit of compute resources you have in that line platform.
Yeah. Okay. Yeah. So the LSST stuff that I've been working on, we've had similar sounding problems. So I think Tom is going to give a talk on that at some point. That might be interesting to look at as well. There we run something like 5 different job submissions and 5 different executors to get access to different resources on the same system. But that's frustrating. Like, I don't want to be doing that. I'd like Parcel to be able to do this for us.
It's interesting though that what you're using the multiple executor for, Akila, is for speaking to different queues. So you could do that with scheduling across multiple executors, or you could have an executor that deployed blocks in different queues depending on whatever. I wonder if, particularly, I don't know if the work queue executor is able to handle that better than the high throughput executor, but I think this is a great request.
Yeah, people keep promising that that's how it's going to solve the problem for me.
I was gonna. This is Dan from Livermore. We have a team that's built such a thing at our site. It uses Celery queues inside pilot jobs, and then it uses a RabbitMQ server to route tasks essentially across multiple machines. They've been running millions of member ensembles across our machines here because we have the same problem even inside our lab, right? We have multiple machines and they all have different kind of capabilities and work queue kind of configurations. Anyway, I was just going to point that out. Merlin, it's open source. You might take a look at it as a proof of concept, at least. They've been running it at scale. It's part of an LDRD project that's ending. Actually, it ended a couple days ago.
Yeah, that sounds really interesting. Thank you for sharing.